Let's do some examples. We've got finding the derivative of the natural log of 2x plus 3. So for something like this, I'm just recognizing it's a natural log. So if I'm taking the derivative, I just want to take the derivative of that argument divided by the argument itself. So my derivative of this is going to be the derivative of 2x plus 3, which is just 2, over 2x plus 3. There we are. We can have examples that maybe are a little bit more complicated. So if we've got this derivative, we're noticing in that argument that we've got division. So we may be thinking, okay, if I take the derivative of the argument divided by the argument, then my derivative of the argument is going to have to include the quotient rule, but we don't necessarily have to, because remember the properties that we were talking about earlier, I'm allowed to expand this into two different logs. So I'm going to go ahead and rewrite it. And we haven't taken the derivative yet, but go ahead and rewrite it as the natural log of x. And since it was division, I'm going to have minus the natural log of x squared plus 1. And that's going to make this one a lot easier to handle. So now I'm going to use my rule, and I've got the derivative of x, which is 1 over itself. And then subtracting the derivative of this x squared plus 1, so 2x over x squared plus 1. All right, kind of depends what you're doing here, but we're just going to leave it like that. You could get a common denominator and combine like terms for sure. Joe, can you sit down, please? So the last thing that I want to do is just go over a few examples of mixing old content with the new, and I think this will be a good refresher of different concepts to kind of try to add these in at the end. So our first one, we're trying to find dy dx of this function, and it is implicit differentiation. So just reminding ourselves how to work through implicit. Remember that anything that just has x's in it, we're going to treat like normal. So if I'm differentiating and I've got this x squared, I'm just going to say 2x. Anytime I get something that has a y in it, I'm going to include that dy dx for the derivative of that, kind of using the chain rule. So my -3 natural log of y, for the natural log of y, my derivative is going to be the derivative of y, which is dy dx, over y. So I'm going to split that a little bit and go ahead and say a -3 over y, because that's like 1 over y, times dy dx. And then again here, our y squared has a y in it, so I've got my 2y, but then dy dx. Our derivative of a constant is always 0. So then from here, remember in implicit differentiation, I'm trying to get that dy dx by itself. So I'm going to go ahead and move my 2x to the other side. And while I'm doing that, I'm going to go ahead and factor out anything on this side that has a dy dx in it. So I'm going to have my -3y, I'm going to have my 2y, and then I've subtracted the 2x over. And then our last step here is to go ahead and divide by everything that is not the dy dx, so that we get a -2x over a -3 over y plus 2y. There we are. And remember, unless something is multiple choice, we can leave it as gross as we want. And for those of you that are still planning on taking the AP test, our new AP test is not multiple choice, so we can leave it ugly. Okay, the other example that we're going to do is reminding ourselves of tangent lines. So we're writing the equation of a tangent line of this function. We've got a natural log in there. And then at the point, or at the x value, x equals 2. So remember, for the equation of any line, I need the slope and I need a point on that line. So in order to find the slope, I want to go ahead and take the derivative of my natural log of 3x. So I've got my derivative of 3x over 3x. So this is kind of interesting because those cancel and ends up being 1 over x anyway. So my slope at x equals 2 is going to be 1/2. And then the other part of this is figuring out a point here. And since I'm talking about x equals 2, I want to figure out f of 2. So we get the natural log of 6. If we wanted to use our calculator to get whatever decimal that is, because this is really asking e to what power is 6, so it's not going to be pretty. But you could go ahead and figure out the decimal, or you can just leave it natural log of 6, and that's fine too. So then we're just putting it into point slope form. Our y minus our y value there, the natural log of 6, equals our slope, x minus our x value of 2. And that is the equation of our tangent line.